All right, let me now get started. Okay, so again, as I just said, what I'm also again, let me just say this. Hold on, let me stop recording. Yeah. Actually, let me just say this, that I think in the other, it might have been this class, I'm not sure, but for some reason the PowerPoint slides like froze and people couldn't see it for some strange reason. Oh, someone says they can't see anything on their screen. I am sharing stuff. If you can't see anything, try refreshing your browser. Sometimes that helps. Okay, but I am sharing the PowerPoint screen right now. All right, so what I'm going to do is I'm going to keep going now. Okay, so someone typed in, Aubrey, try refreshing your web browser. That should help. Hope she can hear me. All right, let me go. Okay, so this is our first example. So again, the first example of factor by grouping, this is what we're doing now. Again, this is what you want to do when you're factoring a polynomial that has 4 terms in it. Okay, now I also posted a link to a website that has more examples as well from a community college. Okay, so when we factor these, you want to remember, we're basically gonna find the GCF first, then we break this up into 2 groups, okay, and then what we do is we find the GCF of each individual group. Okay, that's how we do that. We find the GCF of each individual group. Okay? Okay, here, let me just type this. Okay. Let's keep going. So again, this is one example where that's going to happen, okay? Here, notice we want to get the GCF first. There's a non-zero constant term, okay? We can see that. And because there's a non-zero constant term, right away that tells us we can't factor out x out of every term. In other words, if you go back to the GCF, we will take that m here to be 0. Okay? We're going to take that m here to be 0. Okay? And also notice that 1 is a coefficient, right? 1 is the leading coefficient, in fact. And that's actually nice because that makes it easier, because the only factor of 1 is 1 itself. So that means the greatest common factor among the coefficients and the non-zero constant term is 1. So basically, altogether, what I'm saying is this. The GCF for this polynomial is 1. Okay? The GCF for this polynomial is 1. Okay, so what do we do next? Well, next, what we're going to do is this. What we're going to do is factor this, and we're going to break it up into 2 groups. Now, I'm pointing this out again. Notice I made the 3rd term into addition. Okay, the 3rd term, let me just check something. Let me see how everyone's doing. Okay, the 3rd term again, I made it into addition. Okay, here we go. And that's really what you want to do. It's mostly helpful because what's going to happen is when you form, okay, these 2 groups, using parentheses, if this is subtraction, if it's like this, subtraction and not addition, well, then it's easy to make a mistake when forming those parentheses. With addition, you're less likely to make a mistake. It really just has to do with factoring out a negative. And that's what the next line here is showing. Suppose, for some reason, without thinking, we dove in and formed these 2 groups like so. Well, hopefully you can see from here that if you were to distribute this negative, right, over here, you're not going to get the original polynomial back. So what am I trying to say here? You can keep this as subtraction, But you have to be careful. Okay? You have to be careful, because if you just put the parentheses in without thinking, you're changing the problem in a way that's not what you should be doing. That's not algebraically algebraic. So that's why I like to keep this as addition, because it's easier to avoid that mistake. So just letting you know, you have to be careful. That's what I'm trying to say. Okay. So anyway, we have this polynomial up here. Okay. What we're going to do is we're going to factor each of these two groups individually. Okay, so let's do that. So for the first, when I say factor, I mean find the GCF of each one. So for the first one, okay, for the first one here, well, notice you can see that the smallest power of x is 2, right? The smallest power of x is 2. So in that GCF, that m is 2. And again, we have a coefficient here of 1. And so it's really just like it's just like finding the GCF of the first polynomial, in that the greatest common factor of the coefficients, and the constant term if it's here, but that's not here. So just of the coefficients is going to be 1. So what am I saying here? I'm saying the GCF for this thing, for this binomial, is just x squared. Okay, it's just x squared. So what am I going to do? I'm going to factor out x squared, and that's what I'm doing here. Let me just see something. See how everyone is doing. Is everyone okay? I guess everyone's doing good. Okay. Just want to make sure it's still recording. That's why I stopped for a second, but it looks like it is. So, okay. Okay, let's keep going. All right, good. Good. But that's what we did. So we factored out x squared. Again, how do you factor it out? Well, you have to divide, right? You divide to see what's left over, as you can see. And then you divide into each term, right? When you divide, you subtract exponents. Here it's easier because the x squares cancel. So we get this. Ah, good, here we go. Okay, so now we're going to keep going. So we already factored the first one. That was on the previous slide. Now we're going to handle this. Okay, we'll take the stuff we got from the first slide. We'll put it in shortly. Okay, we will. So we want to now factor the GCF of this group. Okay, well, right away you should be able to see that there's a non-zero constant term. And since there's a non-zero constant term, we have to take our m to be 0. In other words, the smallest power of x is 0. So we can't factor out x. We can't. Okay, that's fine. Notice also the coefficient, the numbers here, the coefficient here is 7. Well, -7, I should say. Here we have -14. Well, if you were to look at the factors of 7 and 14, we're going to disregard the negative shortly. Well, actually, let me fix that. I think it would be better to have that, but here, let me just put -7. Good. If you look at the coefficients of the factors of -7 and -14, this is what you would get. And you can see that 7 itself is the biggest common factor. In other words, the greatest common factor of -7 and -14 is 7 itself. So that tells us the GCF for this thing, okay, is going to be just 7. And that's what we're going to factor out. But remember, it's like I said before, from the second group, you can always factor out, you have a choice of factoring out a positive or a negative number. And since the second and fourth term have opposite signs, you want to factor out negative the GCF. So in this case, we're not going to factor out 7. We factor out negative 7. And by factoring out a negative, now we're going to be able to get a common factor in the parentheses. You'll see on the next slide. Okay, good. Okay, so now we have here both things factored, but now you can see why we factored out that negative 7, right? What do we have? Well, we have a common factor of x plus 2 among both of these, as you can see. And what do we do next? We're going to factor that out, that common factor. And that's what I'm doing here. We get that x plus 2 out of there, right? What do we do next? We divide, because again, we have to figure out what's left over. Okay, and now you divide into each term from here to here, and you're left with this. Okay, let me just explain what happened. Here in the first term, the x plus 2's, they're canceled. Here, the x plus 2's also cancel. We had plus negative 7. I just changed that to minus 7. And we stop here, actually. I mean, normally you would factor us further if you can. We can't factor any further because you can only factor x squared minus a perfect square. In other words, you can't factor this because 7 is not a perfect square. Okay. All right, let me just keep that. Okay, but let me just pause a second. Any questions, though?